Mars has always been a point of fascination, but recent discoveries are rewriting everything we thought we knew. What if the red planet hides a hidden history, one that's slowly being uncovered by the latest technology? Imagine finding evidence that Mars once harbored life or that it might still be home to mysteries we can't yet comprehend. This time we're not just looking at rocks, we're talking about strange green spots, organic molecules, and the discovery of an underground ocean that could change everything we know about our closest neighbor. Mars has long been a target for scientific exploration, primarily because it's one of the few planets where we can find direct evidence of water and organic material, key ingredients for life. Over the years, missions like NASA's Curiosity and Perseverance rovers have uncovered signs that Mars might have once been habitable. These signs, however, are just the beginning. One of the most recent and surprising findings comes from the InSight lander, which has revealed a massive underground water reservoir beneath Mars' surface. This water not only challenges our understanding of Mars' past but also holds the potential to support future human missions. Imagine, while the surface of Mars appears dry and barren, there's a vast ocean hidden beneath, possibly holding secrets about the planet's ability to sustain life. The planet's history tells a different story too. Mars once had a thick atmosphere and a much warmer climate, possibly even allowing liquid water to flow on its surface. However, Mars lost its magnetic field early in its history, leaving it vulnerable to solar winds. These winds gradually stripped away the planet's atmosphere, causing a dramatic shift in its climate, turning Mars from a potentially habitable world into the cold, arid planet we see today. The discovery of this underground water reservoir opens up new possibilities for exploring the potential of Mars to have supported life in the past and perhaps even to support life now, hidden deep below its surface. NASA's Perseverance rover recently discovered leopard spots in Jezero crater, a pattern rich in iron and phosphate, elements crucial for biological processes on Earth. These compounds are often linked to microbial life in water, raising the possibility that Mars once supported similar microbial life. While we can't confirm this, the presence of these elements suggests biological processes may have been involved. Jezero crater was once a river delta, likely shaped by liquid water. This environment could have supported life billions of years ago. Perseverance's Sherlock instrument has also detected organic molecules, further supporting the idea that Mars had the conditions necessary for life. Additionally, the discovery of calcium sulfate in the rocks indicates that water once flowed through this region, enhancing the case for a once habitable Mars. Could the leopard spots be evidence of biological processes that differ from life on Earth, suggesting a unique form of Martian life? These findings invite new questions about the potential for life on Mars, both past and present. The discovery of pure sulfur on Mars by Curiosity provides more than just a chemical finding. It sheds light on the planet's geological history and potential for past volcanic activity. Sulfur on Mars suggests the possibility of underground volcanic regions that may have influenced the climate and created environments where life could have survived. This matters because it helps us understand the conditions that could support life on Mars, which is key for future human missions and colonization. If Mars once had volcanic activity or underground water, it might have been more habitable than we thought, offering insights into sustainable life on other planets. As space exploration progresses, understanding Mars' potential to harbor life or provide resources could have significant implications for interplanetary exploration and future human habitation on Mars, altering how we approach space travel. The discovery of an underground ocean on Mars, revealed by the InSight lander, carries profound implications for the future of space exploration. If this discovery is further explored, it could radically change our understanding of Mars' past and its potential to support life. Mars' deep water reserves could become a crucial resource for future human missions, providing water for astronauts and potentially unlocking new technologies for sustainable living on other planets. However, ignoring or failing to explore this discovery would mean missing a critical opportunity to understand Mars' capacity to harbor life, past or present. The ocean could hold microbial life hidden beneath the surface for billions of years. Understanding this environment could lead to breakthroughs in extreme life forms, offering insights into how life might exist in other harsh environments, including Earth's deep oceans or even on moons like Europa. The risk is clear. Without further exploration, we might miss the chance to answer fundamental questions about the origin of life and the potential for life elsewhere in the universe. Additionally, Mars' underground ocean could play a key role in future human colonization. Without it, our missions may face insurmountable challenges. What's at stake is not just scientific discovery but the future of human exploration beyond Earth. Mars continues to surprise scientists with its enigmatic discoveries, and with the latest data from missions like Perseverance and InSight, we are left with more questions than answers. One of the most intriguing aspects of Mars exploration involves the hidden structures beneath its surface, detected by seismic measurements from the InSight lander. These mysterious signals suggest that Mars may harbor deep geological structures that we haven't fully understood yet. Could these structures be the remnants of ancient volcanic activity or perhaps evidence of an underground network once shaped by flowing water? The detection of unusual seismic activity points to something beneath the surface that could be more than just ordinary geological formations. While NASA has shared significant findings, it's possible that there are still deeper, unrevealed truths hidden under Mars' dusty surface. Secrets that could change everything we know about the planet's past and its potential for supporting life. Speculation on hidden Martian life grows with Mars' underground ocean and the strange seismic signals. A compelling possibility emerges. Could there be microbial life or even more complex organisms hiding in these deep Martian reservoirs? Scientists speculate that if Mars had a warmer, wetter past, these deep areas could have provided shelter from the harsh surface conditions, offering a potential sanctuary for life. As future missions continue to explore these subsurface mysteries, we might find evidence that Mars isn't as lifeless as once thought. The risk of missing a major discovery on the flip side. If we don't push forward with investigating these underground structures and water reserves, we risk losing crucial insights into the history of life, both on Mars and in the broader cosmos. Mars might be a time capsule, holding the answers to questions we haven't even thought to ask yet. The stakes are high. As we send more advanced instruments and rovers to explore deeper regions, the real challenge is deciphering the signals and what they may mean for future human exploration and the search for life. What could be hidden under Mars? The data we have so far hints at something much more complex than a barren planet. The possibility of subsurface oceans, volcanic activity, and even hidden microbial life creates a compelling narrative for future exploration. These findings could potentially revolutionize our understanding of not just Mars but of life's existence in extreme environments, offering insights into how life might survive on other planets or how we might sustain life in extraterrestrial colonies. In the coming years, as technology advances and we send more specialized probes to study Mars' deeper layers, we may uncover the truth behind these mysterious structures. What we find could hold critical information for the future of human space exploration and perhaps even answer one of humanity's greatest questions. Are we truly alone in the universe? As we look to the future of Mars exploration, the next steps are as daring as they are critical. The Mars Sample Return mission could be the key to unlocking Mars's past in a way we've never imagined before. But even with the promise of returning Martian soil and rocks to Earth, there are countless unknowns. What exactly will we find? Could these samples contain evidence of ancient life or reveal more about the planet's lost water reserves? As we continue to push the limits of our technology, the stakes are only growing higher. But the challenges go far beyond collecting samples. As we push for human colonization, we'll need technology that can sustain life in Mars' harsh environment. The MOXIE experiment, which generates oxygen from the Martian atmosphere, is just the beginning. What if we find that creating a sustainable atmosphere on Mars is even more difficult than we thought? The solutions we are building today may not be enough to conquer the planet's challenges, leaving us with questions about how to survive on Mars for the long term. And it doesn't stop there. Future missions will take us beyond Perseverance, with even more advanced robots capable of doing things we can't yet fully comprehend. Imagine self-driving labs on Mars that will extract chemicals from the soil, providing real-time data to unlock even more of the planet's secrets. But can we trust these machines to give us answers? And what happens if the technology fails? As these missions approach, the pressure mounts. The discoveries could be revolutionary, but so could the risks. Will we truly uncover Mars' mysteries, or will we find ourselves faced with even more questions than before? There are critical decisions yet to come, and the road to Mars may not be as straightforward as we hope. The challenges we face in exploring Mars and the possibility of one day making it habitable are both immense and intriguing. As we study Mars' potential for life, we are confronted with a number of key obstacles that could reshape the future of exploration and technology. One major challenge is understanding how to make Mars livable for humans. While we know that Mars may have once hosted liquid water, the planet's harsh environment presents huge barriers to human colonization. The thin atmosphere and lack of a magnetic field expose the surface to damaging solar radiation. Without advanced technology such as radiation shielding and sustainable oxygen production, human presence on Mars could remain a distant dream. But overcoming these obstacles could lead to breakthroughs in material science and new innovations in space architecture, potentially influencing how we live on Earth too. Another pressing challenge involves the terraforming of Mars. If Mars once had a more hospitable environment, the idea of transforming it back into something more Earth-like is captivating. However, the lack of a global magnetic field and the difficulty in reintroducing an atmosphere capable of supporting liquid water make terraforming a massive undertaking. Yet tackling this challenge could lead to innovations in planetary engineering and climate control technologies, which might have applications far beyond Mars, such as for combating climate change here on Earth. Even more mysterious are the strange green spots discovered by the Perseverance rover. These anomalies could point to microbial life or a unique Martian ecosystem. Yet understanding what these spots truly represent is a puzzle we're only beginning to solve. What if they reveal something completely unexpected? Uncovering these biological clues could not only revolutionize our understanding of life on Mars but could also drive collaborations between planetary scientists, astrobiologists, and even biotech industries. If we discover new forms of life or ecosystems, it could open the door to entirely new fields of biological research. While these challenges seem daunting, each one holds the potential to drive significant technological advancements. The obstacles we face could lead to innovative solutions like self-sustaining habitats, breakthrough energy systems, and advancements in space travel technologies. Collaboration, both between nations and industries, will be critical to overcoming these hurdles. By combining the expertise of scientists, engineers, and space agencies, we can push the boundaries of what we know and make Mars colonization a reality, ultimately leading to new frontiers for humanity. The road to Mars will not be easy, but as with any great challenge, the opportunities for innovation are immense. The risks we take today could lead to rewards that extend far beyond our imagination. Mars has revealed tantalizing clues about its past, from underground oceans to possible microbial life, but many questions remain. What if Mars was once a thriving world with life hidden beneath its surface? As we prepare for the next missions, what will we find when we dig deeper into Mars's history? The answers could reshape everything we know about the planet and our future beyond Earth. Mars still holds its secrets, and the journey to uncover them is just beginning. What lies beneath the surface and what will we discover next?